Good morning to all. I am Sumitra, working as an associate professor in Triple Department of R&D Engineering College, and this semester I am handling renewable energy system for 7 semester to students. Now, in this video, I am going to explain how the tidal power is utilized in an efficient manner to generate electrical energy. Before going into the depth regarding the generation of electrical energy from the tidal energy, first we have to know some basic concepts regarding the tidal energy. So, we all know that the ocean water bodies will have naturally some of the form of energy which can be utilized in an effective way to generate the electricity. So, the energy which is present naturally in the ocean water bodies are classified into different types like tidal energy, wave energy, and ocean thermal energy. So now in this video, I am going to explain about the tidal energy and how this energy can be efficiently utilized for the generation of electrical energy. We all know that tides we can categorize as high tides and low tides, and the tides are said to be have a rising period and falling period. And during the rising time, and that is during the rising period of the tides, the water will be getting stored in a reservoir, and which may be either constructed by means of a dams or the shores, and the potential energy of the such stored water is used to generate the electrical energy, which is similar to that of conventional hydropower plant. So, in order to utilize the tidal energy in an effective manner, the difference between the low and the high tide it utilized, and it should be of at least some 4 meter. So, if you are in need to trap the tidal energy in order to generate electrical energy, we should at least have a height difference between the high tide and the low tide of minimum 4 meters. So if that difference is minimum 4 meters, then we can effectively trap the tidal energy for the generation of electrical energy. And we all know that tides are known as the periodic rises and falls of large water bodies, and these are getting created because of one major concept called gravity. So, the gravity is the one main force which will create the tides. So, ocean tides are result from the gravitational attraction of the sun and the moon on the oceans of the earth. Okay, then there exist different types of tides called the spring tides and neap tides, based on the magnitude and based on the duration and all. So, whereas the spring tides or the special strong tides, which occur when the earth, moon, and the sun are in a same line. So, or otherwise, we can say that the gravitational forces of the sun and the moon both contribute to the tides. So, since the gravitational force uh, offered by the moon and the sun are in the same direction, they are aiding each other. So that's why it can capable of generating the what to say, the strong tides called the spring tides. And generally speaking, these nature of tide, that is the spring tides, can occur during the full moon and the new moon period. And on the other hand, your neap tides or called as the weak tides, and they occur when the gravitational forces of the moon and the sun are perpendicular to one another with respect to the earth. Since they are acting in opposite direction, the overall gravitational force exerted by the sun and the moon are not pointing in the same direction, the magnitude will be less. That's why it is resulting in the formation of the weak tides called neap tides. So this is the one which is showing the how the neap tides and strong tides are creating, or spring tides are creating. And when the landmass is at 90 degree, then the water around it is at low tide, and then when the landmass is in line with the earth moon system, then the water around it is said to have a high tide. Okay, and then this nature of the spring tide and the neap tides also results in flood currents and ebb currents. So, what do you mean by flood current is the currents which is moving in the direction of the coast, and the current which is moving in receding from the coast is said to have the ebb current nature. And we can say this tidal power as also one form of hydropower that is going to convert the energy of the tides into the electricity or any other useful forms of power. And basically speaking, this power is, that is, this tide is created by the gravitational effect of the sun and the moon on the earth system. Okay. The major thing is the earth is the responsible for causing a cyclic movement of the seas. That is, tidal energy is an resultant of a cyclic movement of the sea. And also we can able to predict how much of energy, or tidal energy is an entirely predictable form of renewable energy. And then coming to the history, we have the first tidal power station which was developed in France, which is having a capacity of 240 megawatts, and it is also stands as the second biggest tidal. And then next one is the types of tidal plant, or otherwise, okay. So here we have example that is stating that where we have the first tidal power location and what about the installed capacity and all. And then regarding India, the long coastal line with estuaries and gulfs in India has a strong tidal range and which is having an height to move the turbine for electrical power generation. Okay, and then we have certain locations, site locations, which is having a reasonable tide height and also which is having an estimated power potential of so and so megawatts. Let me tell some of the things. For example, the Gulf of Cambay, which is at Gujarat, with having a tide height of 11 meter and having an estimated power potential of 7,000 megawatts. Similarly, in Gulf of Kutch, Gujarat, we have a tide height to be of 8 meters and whose estimated power is about 12,000 megawatts. And similarly, Ganges Delta in Sundarban, West Bengal, we have a tide height of about 5 meters, having a potential of about 8,000 megawatts. So these are the different tidal potentials in India. And then first we need to know how much is the energy available in the form of tidal things. So we all know that potential energy and kinetic energy are the two components of energy which is responsible for creation of the tidal energy. Potential energy is nothing but the work done in lifting the mass of the water above the ocean surface, which plays a dominant role in the energy production from the tidal energy. And we all know that the expression for the tidal energy by using the potential energy concept is E is equal to zero point 0.5 rho g a h square, where E is the energy and g is the acceleration of the gravity and rho is the seawater density and a is the area of the seawater under consideration and z is the vertical coordinate and h is the tide amplitude. Then we have some of the tidal plant facilities. The tidal plant can be constructed even in the presence of tidal barrages or tidal current turbines or dynamical tidal power plants. So here is an example for tidal barrage system, which mainly utilizes the potential energy of the tidal tides, and these are generally built across an bay, and it consists of a turbine, sluice gates, embankments, and ship locks, etc. So here we have a barrage and the sluice gates, and depending upon the level of the tides, this sluice gates will be open, getting open, and the water can be entering, and which in turn drives the turbine that generate the electrical energy. And how the tidal power plant is working means, in a tidal energy power plant, basically water is getting collected and during high tides in an artificial basin, and the same water is getting released during the period of the low tide. This is a basic concept of tidal power plant. So during the high tides, the water will be getting stored in a basin, and during the low tides the same water is getting released, and these water is used to spin a hydraulic turbine, which in turn coupled to a generator. So while the water passing on through the turbine, it will run the generator, thereby converting the mechanical energy to the electrical energy. So in order to come out with this, with such a process, we need a powerhouse and a dam to form the basin, and also to permit the water, we are in need of the sluice ways, that is which permits the water from either from basin to the sea and vice versa, right? And the main function of a dam is to create an obstacle between the sea and the basin. So the sluiceways are used to either fill the basin during the high tide or empty the basin during the low tide. And we have different types of tidal power basin. So as I mentioned earlier, the basin system is the one which is one of the method used for harnessing of tidal energy. And how this basin can be formed means by enclosing a portion of the sea behind the erected dam. The dam should includes a sluice valve, which will allow open and allow the tide to flow into the basin during the tide rise periods, and it is getting closed. Okay. So now there exist different types of basin, like a single basin tidal power plant and the double basin tidal power plant. Then coming to the single basin tidal power plant, this is the simplest way of power generation, and this is the simplest scheme available for generating the tidal power with a basin arrangement. It consists of a single water reservoir, which is getting closed off by constructing a dam or a barrage, and the sluice gates are large enough to admit the water during the tides, so that the loss of it is small. It is provided in the dam in such a way to prevent the loss. Okay, so in single basin tidal power plant itself, we have two features: one way single basin system and two way single basin system. So in case of one way single basin system, the basin is initially filled with the seawater by passing through a storage tank during the low tide period. When the water level in the basin is higher than that of the sea level at the low tide period, the power is generated by emptying the basin water through the turbine generator. So this can be used. This type of system can be used to allow the power generation only for about 5 hours, and it is followed by refilling of the basin. So this is the constant regarding your one way single basin system. And then in case of two way single basin system, this allows the power generation from the water moving from the sea to the basin, and then to the low tide moving back to the sea. So in order to accompany these two process, we are in need of a bigger and more expensive turbine, which is a drawback. So that's why most of the cases single basin system with the one way scheme is applicable. And this basin single basin system has a main drawback, which is nothing but the intermittent power supply, and we can able to harness only of about 50 percentage of the available tidal energy. So this is the main case regarding, or main drawback regarding your single basin system. So coming to the two basin system, see, whatever I explained you, that is given over here in a single tidal. The powerhouse is located, and the hydraulic turbine in the powerhouse operates during the discharge of water from the basin during the low tide, and this results in intermittent operation, which is the main drawback over here. However, this can be rectified in a case of double basin system, where the power generation is possible both during the low as well as the high tide. So this is the schematic diagram which shows you the representation of double basin tidal power plant. So this is just an improvement of the single basin. In this, a constant and continuous output can be maintained by suitable adjustment of the turbine valves, which will suit the head under the turbines in which it is operating, right? So here it is having an inlet sluice and outlet sluice, and this is the dam which has been constructed. And here we have a power plant, and this is the upper basin and the lower basin. A two basin system is having a capacity to regulate the power output of an individual tide. So this system provides a partial solution to the problem of getting a steady output power from a tidal scheme. So in the double basin system, we need to construct the two basin which are at two different levels. So in order to that, a dam is provided with them. The inlet and the outlet sluice gates valves are made in the dam. The water level in the upper basin is maintained above the level of the water in the lower basin, and the upper basin is filled with water during the high tide, and the lower basin is evacuated during the low tide, and therefore a permanent head that is different in water discharge will be provided or produced between the upper and the lower basin. So when a sufficient water head is created, the turbine of the power plant are started, and the water gets started flowing from your upper basin to the turbine. So which it in turn then discharges to the lower basin, and this is how the electrical power is getting generated in case of double basin system. So in my next video, I'll be explaining you um, about the ocean thermal energy, how the energy can be trapped in an efficient manner from the oceanic waves. Thank you all.